Let's look at this problem. The point P with coordinates A and B in the xy plane is first rotated counterclockwise by 90 degrees around the point 1 and 5, and then reflected about the line y equals -x. The image of P after these two transformations is located at this point. This is the ending location of point P. And the question is, what is B minus A? And basically what we need to do is to find the original two coordinates of point P. Alright, so this is a typical analytical geometry problem. And what we need to do is to draw these coordinates and then try to perform these two operations. We have operation 1 and operation 2. We need to perform these two operations reversely so that we can retrieve the original location of point P. Alright, let's first get the coordinates. So let's say this is our x-axis and this is our y-coordinates. Good. We need to get a longer line on this side. Good. So like we said, what we need to do is to perform the two operations reversely. Therefore, we need to find the crucial points or lines. And the one line we need to find out is this, right? Because we need to reflect the point around it. Therefore, let's get the line first. So we know that this is a 45-degree line through the origin of the coordinates. So this is our line of y -x. And then we have another crucial point, which is this point. This is the center of the rotation. Therefore, let's mark that out. 1 and 5. So let's say this is 1 and this is 2. And the 1 and 5, we need to find 1, 2, 3, 4, 5. And then let's get a few more points. 6, 7, 8, and 9, and so on and so forth. Right? This is our y-axis. So this is 9, 8, 7, 6, 5, 4, 3, 2, 1. Good. And then now let's get the grid on the negative part of x-axis. So we have -1, -2, -3, -4, 5, 6, and 7, right? We need a few grid points. So that is -2, 3, 4, 5, 6, 7. Alright, so now we are ready to draw our point of P. So first, we only need the final location of point P, which is -6 and 3. So this is -6 on the x-axis, and the coordinates on the y-axis is 3. Therefore, our final location of the point P is at this point. So we'll call that P2. So this is -6 and 3. And what we need to find is this P, right? So let's just call that P or P0. So like we said, we need to perform these operations reversely. Then we need to first find the location of this P1 before this reflection. Then what is the coordinates of that point? So we need to reflect this point P2 reversely about this line. And then that will be like this. Right? Then the question is, what is the coordinates of this P1? And the answer is actually quite simple. Let's call this P1. The coordinates of P1 is actually the swap of the coordinates of P2. Therefore, that has a coordinates of -3 and 6. Right? So this is minus 6 and 3, and this is minus 3 and 6. So let's remark this. So we'll mark the coordinates of P1 in here, minus 3 and 6, right? So this is very easy to find out. And now we need to find the coordinates of the very beginning location of P, right? And then what we did in there, that is the rotation counterclockwise by 90 degrees around a center point of 1, 5. So let's first mark that point. So this is our center point, 1 and 5, right? And then therefore, in order to retrieve our original point of P, we need to rotate this P1 clockwise by 90 degrees. Therefore, let's first call this center point O. And then we will connect P1 and O. We'll draw a line in here. Alright? And then we'll draw a perpendicular line through this point O. So it'll be like this. Right? It'll be perpendicular to P1O. And since it's a rotation, then this length, the distance from P to O, is equal to the distance from P1 to O, right? So that is how the rotation works. So it's basically in here. And this is the right angle. And now the question is, what is the coordinates of P, which is A and B? What is the quantities of A and B? And now we need some help from the classic geometry. And it will be the easiest way to get the coordinates of A and B. And we will see right away. So what we want to do is to draw a horizontal line through this point O. So this is the horizontal line, right? And then this line can be expressed by this equation, y equals 5, right? So this is very straightforward. And now let's look at this triangle. Look at this triangle. This triangle. Of course, we know that this is a right triangle, right? This is 90 degrees. So let's call this point E. And we want to draw one more line. That is a perpendicular line through this point P to this y equals 5. So it'll be a line like this. And some students may wonder, why do you want to do that? And the answer is actually very straightforward. Why do we want to draw these perpendicular lines? And this is because all these lines are parallel either to the x-axis or the y-axis, which is exactly the way we find the coordinates, right? Good. And we call this intersection F. Be careful. Now I want to make a claim. Let's see if that is true. So I want to make this claim. The right triangle P1EO is congruent to this triangle. This right triangle PFO. Is that right? This is our claim. And certainly for this multiple choice problem, we don't need to prove this. But actually this should be very straightforward to you. First, because this is a right angle. Therefore, the sum of these two angles, this one and this one, shall be 90 degrees. And these two triangles are right triangles. Therefore, this angle with a dot equals this angle, right? And this angle with a circle, which is P1OE, shall equal to this angle, FPO. And at the same time, we have P1O equals PO. That is how the rotation works, right? And then we know that these two triangles are congruent. So this claim is true. And why is that helpful to us? Here's the deal. Since we know the coordinates of P1, which is -3 and 6, then we know this length, EO. The segment EO just equals the absolute value of the x-coordinates of P1, which is 3, plus 1, which is the x-coordinates of the point O, and that equals 4. That's the length of EO. And then we know that the length of P1E equals the y-coordinates of P1, which is 6, minus the y-coordinates of O, which is 5. And it's equal to 1, right? And then from the pair of congruent triangles combined with this information, so we combine all of these, we get this. The length of PF equals EO and equals 4. And then OF equals P1E. These are the pairs of corresponding sides of the two congruent triangles, right? So it equals 1. Good. So with this pair of information, we know that this is 1. Then what is the x-coordinates of P? So certainly A equals 2, right? So it has to be like this. And then at the same time, we know that this is 4 from P to F. This is 4. And for the point F, it has a y-coordinates of 5. So from 5, we plus another 4. Then we know the y-axis of P is 9, right? That is basically B equals 5 plus 4 equals 9. Good. So now we get the values of A and B. So let's write it in the pink color. So we know that A equals 2 and B equals 9. What is the question? It is asking about this quantity or this expression, B minus A. Therefore, that is 9 minus 2, which equals 7. So our final choice is D. If you like this video, please give it a like and subscribe the channel. If you have questions, please leave a comment.